We present HaptiCraft, a modular handheld haptic controller designed to mimic the shape, mass distribution, and haptic properties of virtual objects. HaptiCraft is made up of cube-shaped modules, each with its distinct unimodal functions. By assembling several modules, users can create a custom controller that matches the shape and mass distribution of the virtual object they're interacting with. Also, combining multiple modules gives the user a range of multimodal haptic feedback. The controller communicates wirelessly via Wi-Fi, using predefined communication protocols. One big advantage of HaptiCraft is that a single power module can power all the connected modules. For example, in a VR scenario, a user can feel the sensation of a gunshot with both impact and vibration feedback when using a pistol-shaped controller. Based on the design requirements in Section 3, we created HaptiCraft with 3 types of modules: haptic, utility, and connector modules. The haptic modules provide distinct haptic effects based on their type: a shape module for the base shape without dynamic haptic effects, a vibration module for vibrotactile stimulus, a thermal module for temperature changes, an impact module for short, strong effects, different from vibration, a variable inertia module that adjusts mass distribution to match virtual objects, and a variable stiffness module that renders different stiffness levels in real time, using smart materials like Emmer fluid. Each haptic module contains the microcontroller unit, circuit, and actuators. Utility modules don't provide haptic effects, but serve specific functions like communication, touch button input, power sharing, and tracking in VR. Here's an example of how to connect the power module. Finally, the connector module is used for firmly grasping, wielding, and manipulating the assembled controller, while maintaining power sharing. To connect 2 modules, users insert the connector and rotate one module 90 degrees clockwise. We explain the communication protocols used for the PC to communicate with the communication module, and for the communication module to connect with other assembled modules. We evaluated the technical capabilities of the HaptiCraft through comprehensive function tests, and each module performed its haptic functions as expected. We also assessed the perceptual effects of uni and multi-modules through 2 user experiments. For more details, check the paper. Designing a controller and assigning its haptic properties manually can be tricky and time-consuming. To make it easier, we developed a controller authoring tool for HaptiCraft. Here's a step-by-step guide to how it works. In the controller design step, users can design their controller configuration with various modules. It starts with placing a power module in the center of the tool. To add new modules, users choose from icons in the new module panel, and click on the faces of both the new module and the existing controller to attach them. If changes are needed, removing the last attached module is simple. Users can rotate and zoom in on the controller by clicking, dragging, and scrolling with the mouse wheel, making it easy to design their custom controller. In the haptic sensation design step, users assign haptic properties to their designed controller. They add a haptic track to the timeline by selecting the corresponding module, and create a haptic layer by dragging the mouse over the track. Users can assign and adjust haptic properties using icons and sliders on the haptic layer panel. Multiple haptic signals can be added to a single track, and different properties can be used at once by creating multiple tracks. Users can preview the haptic sensations by clicking the play button, and fine-tune the stimulus as needed. Additionally, users can preview and delete individual layers or tracks. Once the design and haptic properties are set, users can physically assemble the controller with the actual modules. The UI helps by visually showing the controller and highlighting the next module to attach with blinking cues. Here's an example of how to adjust haptic stimuli, combining vibration and impact, along with the corresponding output results. We also introduced the HaptiCraft description format, based on JSON, which allows users to reuse and share their configurations easily. We then evaluated the tool, using the technology acceptance model. The results showed that our tool has low technological complexity and a high intention to use. Finally, we conducted a VR user experiment to evaluate the haptic experiences, using controllers created with HaptiCraft. We set up 7 different use scenarios and created corresponding handheld haptic controllers for each. We then evaluated user experiences. The results showed that the user experiences with controllers made using multimodal HaptiCraft were rated higher than those with unimodal controllers and commercial controllers.